this is the second half here of 7/8. I decided to do one more like what you'll see on Delta Math today. So, right? So you start with 100%. 100% as a decimal is just 1. So if I'm working with the formula y equals ae to the kt, there we go, to the kt, then I know that I start with 100% as my starting value. Then I know that when it says the mass decreases by half, half as a percent is 50%, right? Which as a decimal is 0.5. So that's actually what I'm going to be plugging in for y. I know these aren't exact values. Element X is a radioactive isotope such that every 5 years but that's what I'm going to use is these percent values. I don't know what K is. That's actually what you're solving for this time. And then T is going to be the 5 years, because that's how long the half-life is 5 years. So I just multiply that there. So now what I'm going to do is solve for K. So the first thing I need to do is get rid of this multiplier of 1. If it was anything but 1, you would need to divide it away. But it's just 1, so actually, this is just 0.5 equals E K parentheses 5. Which, for giggles, I'm going to rewrite it the other way. Make that an arrow instead. Its mass decreases by half. Given that the initial mass of... I can't plug this e to the k5 in my calculator because of that variable k, but what I can do is a nice happy circle method, which would give me the log base e of 0.5 equals k times 5, which I know log base e is actually just ln of 0.5, and that's a happy number I can just plug into my calculator. And with this 5 being multiplied by the k, I can just divide that. So right now what I'm doing is I'm picking up my calculator and I'm typing that ln button, the third one down, second one below the second key. And then I just hit 0.5 and close those parentheses. And with mass of a sample of element X is 590 grams, how much the element would remain after... You can go ahead and hit enter here if you want, and you get negative 0.693147181. And I'm going to go ahead and divide that by the 5. And my answer is negative 0.1386, yada, yada, yada. It makes sense that I have a negative number because it's getting smaller. Half-life, I should have less as time goes on. So that would be my k value if I was trying to write an equation. It would be y equals this value that we actually started with, according to the word problem, is 590. Right, I got that right there if you're wondering. Times e to 23 years to the nearest whole number. This one is actually a little... The k, negative 0.138 times t. If the directions were to just write the equation, that's what the answer would be. Now the directions say, find out how much is left after 23 years. So I need to plug in 23 right here. Now the problem is, this was a rounded number. So my calculator, which I haven't cleared yet, still has that big long decimal, I'm just going to hit times 23, so that it will automatically take that long decimal and multiply it by 23. You should get negative 3.188477031. Now I'm just going to, you can go ahead and hit clear if you'd like. Now I'm going to hit my second e to the x, but instead of typing in that big long, interesting, because what we're going to decimal, I'm just going to do second answer, and it will automatically plug that whole thing in for me. And it should be 0.041234622. Next, I'll be multiplying that by 590. So I just hit times 590, and I get 24.3. The directions say to round to the nearest whole number, so the answer would be, the answer would be 24. What I have to do is do math without all of the numbers given to us. So how are we going to do that? Well, first of all, I recognize that at the beginning, when I have 590 grams, that's 100% of all of the grams.